What is up, math superstars? In this edition of Mr. Peterson Presents, I'm bringing to you how to write and solve equations. And so if you watched my last video about translating expressions and equations, it is pretty close to the same, except now we're going to be very purposeful in defining the variables and actually solving the problem now. So let's take a look at our first example here. So we have Kelly's test score is 6 points higher than Michelle's. So if Kelly's test score is 88, what is Michelle's score? And so our first step is we got to define our variables here. So we're going to do K for Kelly's tests. So Kelly, and M is going to be for Michelle. So right now we just define the variables. And so on things like quizzes and tests, when we ask you to write out the steps and you have to define the variables, this is exactly what I'm looking for. Now we need to build out our equation here. So we're going to take it from this first little part right here. So Kelly's test score is. So is our equal sign. So we know that is our equal sign. Kelly's test score would be K. And then is 6 points higher than Michelle's. And so we know that's more than. So we can write this as M plus 6. And so right now we're given our equation. We have two variables, but we're also given some key information. Kelly's test score. So Kelly's test score is equal to 88. So what we can do for that lovely little piece of information. So we know that K is equal to 88. What we can do is we can substitute K for 88 and then rewrite our equation. So now what we got to do is now we have to solve for M here. And so what we do is we do our our handy dandy one-step equation here. So let's go ahead and rewrite our equation here. I'm just going to rewrite it on the side here so you can see it. So we have 88 is equal to M plus 6. We're going to go ahead and subtract 6 from both sides of our equation to give us M being equal to 82. So if we're going to write this out, Michelle's test score. So M, we know that she scored an 82 on that test. Our proper label here, we can label this 82 points on this test to give it a proper label. So now let's go ahead and try this problem. So the lowest point in Louisiana is 543 feet lower than the highest point in Louisiana. The elevation of the lowest point is -8 feet. So we need to write out an equation and solve for the highest point. So very first step here is we're going to define our variables. So we have, let's use L is going to be our lowest point and H is going to be the highest point. So we just, very simple, define your variables. So we have to figure out, now we got to figure out what our equation is going to be here. So the lowest point in Louisiana is, so there's a keyword is. So let's go ahead and build this out now. L is equal to 543 feet lower than. So that's the same as less than. So what we do is we got to switch the places of H minus 543. We're given some other key information. The lowest point. So we know that L is going to be equal to -8. So let's go ahead and substitute that in. So -8 is equal to H minus 4. I keep doing that. 543. Now let's go ahead and solve for H. So I'm going to go ahead and rewrite it here in my little space that I have. So to get H by itself, I'm doing the inverse of subtracting 543, so let's go ahead and add that to both sides. So we can find H to be equal to So we can come out that as 535. And so let's go ahead now. So we know that H is equal to 535. And we're going to do a proper label on it. So we know that we're measuring in feet. So let's go ahead and put that appropriate label on there. So now this video is just going through some examples here of what we need to do, and the expectations are, since this is a Math 7 video, to go through and solve these different problems. So here this question says, I bought a sweater and a hat and paid a total of $32. The hat cost $8. How much did I pay for the sweater? So we have to label two variables here. So our two variables are the sweater, let's call that S, and the hat, let's go ahead and label that as H. So what we have here is, we know that the total here is 32, so that's going to be equal to 32. And then we're doing the sweater plus the hat. We know that some key information here that we're given, the hat costs $8, so it's going to fill that in our equation. S plus 8 is equal to 32. And now let's figure out what S is going to be equal to. So let's go ahead and subtract both sides from 8. So we know that our sweater is equal to 24. And so we need to give that a proper label. Our answer for that sweater, our sweater is equal to $24. Let's keep on going with our examples here. So it says, after you withdraw $40 from your checking account, the balance is $287. So we need to find out our balance before this withdrawal here. So we have our balance, our original balance. We'll give that as B for our balance, and W for withdrawal. So we have the word is here, is equal to $287 at the end. So our original balance minus the withdrawal, because we're taking out money, is going to be equal to $287. We got some key information. That withdrawal was $40, so our balance minus $40 is equal to $287. Let's figure out how much money we had in the very beginning. So let's go ahead and add 40 to both sides of our equation. We're doing inverse operations here to figure out what our original balance is going to be, $327. So the way we're going to write that is B is equal to, we put our dollar sign, $327 that you started with. Now you only have $287, and that is sad because you spent $40. Here's a question. After receiving $25 for her birthday, Latisha has $115. How much did she have before her birthday? So for before her birthday, let's go and label that as B. So this is B before her birthday. Before her birthday. And then she received, so we'll label that as R. We'll call that as receiving money. I can spell promise. So beforehand, she received some money. And then what she has now is she's rolling in the cash, $115. We're going to substitute some key information in. Receiving $25. That's the R there. So let's go ahead and put in 25 for the R. We're just substituting for that variable. Let's figure out how much money she had before. So let's go ahead and solve this one-step equation. Let's go ahead and subtract 25 from both sides of our equation. So before her birthday, she had a grand total of $90. So the way we're going to write that is B is going to be equal to $90 before her birthday. Now she's a little richer. So we have a temperature question. We're just going through these different types of questions. If you want to give these a try on your own, feel free to do so. So here we have, after the temperature had risen 12 degrees Fahrenheit, The temperature was now 7 degrees. So we got to find the starting temperature. So we have the starting temperature. We'll call that as S would be our starting temperature. Our start, the rising temperature, let's label that as R. And when it's all said and done, it was all 7 degrees, which is very cold, probably as cold as what it is this morning. And if you're watching this on the 12th, it is February 12th, it is freezing cold outside. So what we set up our equation, S, and then it's rising plus R is equal to 7. Yes, you heard that correctly, 7. So it's risen 12, so it's going to fill in positive 12 for the rising. That's always a good thing. Let's figure out what our starting temperature was. And this is even brutal to even try to do. This is going to be nasty cold. We're going to subtract 12 from both sides. Our starting temperature is equal to -5. So the way we're going to write this, our starting temperature is equal to -5, and then our label is right there, degrees Fahrenheit, which is frigid, freezing cold. Turn to your neighbor and go, that is super cold. We got some more problems going on here. So we have the population of South Africa is 4 times the population of Greece. The population of South Africa is 44 million. Write and solve an equation to find the population of Greece here. And so let's go ahead and do our awesome little variables here. It's going to help us out. So South Africa, I'll label that as S for South Africa. And then let's go ahead and label G as Greece. Probably should capitalize that. So let me go ahead and erase that and capitalize it into Greece. Very nice. It says the population of South Africa, we're given some information, is 44 million. And then, the population of South Africa is, so South Africa, S, is going to be equal to 4 times that of Greece. So we're going to label that as 4G. And so we're given the information, 44 million. What we can do is just write that as 44. So we're not going to write out all those zeros. Our label is going to be million. So let's go ahead and label that as 44 is equal to 4G. And now let's get the population of Greece by itself. So we're going to divide both sides by 4. So we know that Greece is equal to 11. So it's not just 11 people. Our label here is in the millions. So we can say that Greece is equal to 11 million. The label is important. So here we have this question, a class of 30 students. It's separated into equal sized teams, resulting in 5 students per team. How many teams are there? And so here we have S for students and T for team. And so now we need to figure this out here. So resulting in 5 students, that's going to be equal to 5. So this question's a little different. We start with the 30 students, and we're going to divide them into equal teams. We're going to divide that by T. We don't know what that is yet. So this one, a little different than what we've seen before, but we can figure this out. We need to figure out how to get T by itself. So we need to do a couple steps to get T by itself. First step is, let's multiply both sides by T. What this does, we cross out our T's and we're left with 30 is equal to 5 times T. Because if T is in the denominator, it's going to be kind of tricky to figure out what T is. We can figure out in the head, but this is how we show those steps that are oh so important. So our next step, now we have 30 equals 5T. Now we can divide both sides by 5 to figure out that T is equal to 6. And so when we write this out, T is going to be equal to 6 teams. And make sure you put a nice proper label on that. So now we're given this problem. So it says a team has a total gain of 15 yards over several plays with an average gain of 5 yards per play. How many plays are represented? So here we have yards. We're going to label that as Y. And we have plays. Let's label that as P. And so it results in 5 yards per play. So that's going to be equal to 5. And the way we do this, we have 15 yards per play. We're trying to figure out what P is going to be equal to. So just like our last example, let's go ahead and kind of rearrange this problem so we can actually do the one step properly. So let's multiply both sides by P. So we're left with just 15 is equal to 5P. And so what we do next, now let's do our one step. Let's divide both sides by our coefficient of 5. And we're left with P is equal to 3. And so the way we would write this, P is equal to 3 plays. So now we have the total cost. So there's a total cost problem equals the price times the amount. So we're given this equation already. We just got to figure out what in the world's happening with our word problem. And so we have granola bars are on sale for 50 cents each. So there's our price. So if Brad paid $5 total for the granola bars, how many bars did he bought? And so we have our total costs. So let's write down some information. Our total costs will be $5. And then the price is going to be 50 cents a piece. And then we're trying to figure out the amount of bars he bought. Let's go and label that. Let's give that a label of B. Sounds like good for granola bars. And let's go ahead and use this equation here. So our total cost is $5 is equal to our price of 0.50 times B. And what we're going to do now is to get B by itself, let's go ahead and divide both sides by 0.5, 0.5, and we're left with these cross out here, so we're left with B is equal to 10. And so we can say that our friend Brad here, so he's kind of funny, the amount of bars he bought 10 granola bars. So now we're given this equation, distance is equal to rate times time. And so on a family trip, the Rollins family drove an average of 63 miles per hour. Find out how long it takes them to drive 588 miles. So we got to figure out, using this equation here, which parts we can fill in and which parts are a variable. So we got to figure out how long it took. So T would be equal to time. So T is what we're trying to solve here. So our rates, so it's how fast we are driving, is 62 miles per hour. And our distance is going to be 558 miles. You're just writing down some key information to help you out. Let's go ahead and fill it right into this equation right there. So our distance will be 558 is going to be equal to our rate of 62 times T. So now we need to get T by itself. So now we just got to get T by itself. So let's go ahead now, doing a one step, divide both sides by 62. And what you can do for this problem is you can use a handy dandy calculator to do this problem here. So we're figuring out our time is going to be equal to, when we do it in our calculator, comes out to 9. So we can say our time is equal to 9. So we're talking about seconds, minutes, or hours. So our key is found in the rate right here. We're talking about hours. So this little family road trip took 9 hours to get to grandma's house.